So, you're in the market for a new computer. You walk into a store, or more likely, you're scrolling online, and you see all these options. There are desktops, all-in-ones, gaming PCs, and then there's this other category, workstations. They often look like beefed-up desktops, sometimes a little plain, but with price tags that can make your eyes water. And that begs the question, ever wondered what sets a workstation computer apart from a regular desktop? They both have a CPU, RAM, and a GPU, right? On the surface, they seem pretty similar, but the reality is they're built for fundamentally different purposes and different users. The line between a high-end consumer PC and a workstation can seem blurry, especially with how powerful gaming rigs have become. But trust me, the differences are there, and they're significant. It's not just about slapping in the most expensive components and calling it a day. It's about a whole philosophy of performance, reliability, and purpose-built engineering. So, in this video, we're going to do a deep dive. We'll break down the key differences between a standard desktop and a true workstation, point by point, so you can understand what you're really paying for and which one is actually the right tool for your job. We're going to look past the marketing and get into the genuine, detailed points. We'll talk about the specific hardware choices, the features you won't find on a spec sheet at first glance, and the reasons why a creative professional or a scientist might choose one over the other. By the end of this, you'll have a crystal clear picture of what makes a workstation, well, a workstation. Let's get into it. Alright, so let's start with the most obvious difference: performance and hardware. This is where you see the biggest numbers on the spec sheet. With a regular desktop, you're looking at consumer-grade CPUs, think Intel Core i5, i7, or AMD's Ryzen 5 or 7 series. These are fantastic processors, more than capable for everyday tasks, web browsing, and even high-end gaming. But workstations play in a different league. They typically feature server-grade or professional-grade CPUs like Intel's Xeon or AMD's Threadripper Pro. These chips aren't just about high clock speeds, they're about core counts. We're talking dozens of cores and threads, designed for massive parallel processing tasks like rendering a complex 3D scene or running intricate scientific simulations. Then there's the GPU. A gaming PC might have a top-of-the-line NVIDIA GeForce RTX or an AMD Radeon card, which are optimized for one thing, pushing the highest possible frame rates in games. A workstation, however, will have a professional-grade GPU, like an NVIDIA RTX Ada generation, formerly Quadro, or an AMD Radeon Pro. These cards are built differently. Their drivers are optimized for stability and precision in professional applications. Think CAD software, video editing suites, and 3D modeling programs. They're engineered for accuracy in complex visual computations, not just raw gaming speed. This means smoother viewport performance and fewer rendering errors in your professional workflow. And finally, RAM. Your average desktop might have 16, maybe 32 gigabytes of RAM, which is plenty for most users. Workstations, on the other hand, start there and go way, way up. It's not uncommon to see workstations configured with 128 gigabytes, 256 gigabytes, or even terabytes of RAM. This isn't just for bragging rights. It's a necessity for professionals working with massive datasets, 8K video timelines, or huge architectural models. It's about having the headroom to load entire complex projects into memory at once, which is a night and day difference in performance compared to constantly swapping data with your storage drive. So performance is one thing, but what happens when you're on a tight deadline and your computer crashes? That's where the second key difference comes in: reliability and durability. Consumer PCs are built to be affordable and perform well for a few years of typical use. Workstations are built with the expectation that they will be running at or near 100% load for hours, days, or even weeks on end without failing. They are engineered for mission-critical tasks where downtime literally costs money. This philosophy starts at the component level. One of the cornerstone features of a workstation is ECC, or Error Correcting Code, memory. Standard RAM in a consumer PC can occasionally experience single-bit errors, a 1 flipping to a 0 or vice versa, due to cosmic rays or electrical interference. For most people, this might result in a rare, random crash that you just reboot from. But in scientific computing or financial modeling, a single flipped bit could corrupt your entire dataset and invalidate hours of work. ECC memory has an extra chip that detects and corrects these errors on the fly, ensuring data integrity and system stability under heavy load. It's a feature you almost never find in consumer-grade machines. This focus on durability extends to everything else. Workstation power supplies are often higher wattage, more efficient, and rated for continuous operation. The cooling systems are also a huge step up. Instead of just focusing on peak performance for short bursts like in gaming, workstation cooling is designed for sustained thermal management. You'll see larger heat sinks, more robust fans, and carefully designed airflow channels to ensure that even when the CPU and GPU are pegged at 100% for a full day of rendering, temperatures remain stable and performance never throttles. The entire chassis is built for longevity and serviceability, a true industrial-grade tool. A computer is an investment, and for professionals, that investment needs to be flexible. This brings us to expandability and customization. While you can certainly build a custom gaming PC with lots of options, workstations are designed from the ground up for maximum internal expansion. They anticipate that your needs will grow over time. A standard desktop motherboard might have 4 RAM slots and a couple of PCIe slots. A workstation motherboard is a completely different beast, often using larger form factors to accommodate a much higher density of components. Let's look at the slots. It's common for a workstation to have 8, 12, or even 16 DIMM slots for RAM, allowing for those massive memory capacities we talked about earlier. This means you can start with a reasonable 64 gigabytes and scale up to half a terabyte or more down the line without replacing your entire machine. The same goes for PCIe lanes. Thanks to those Xeon and Threadripper CPUs, workstations have a huge number of PCIe lanes available. This allows you to run multiple high-end GPUs, install several super-fast NVMe SSDs, and add specialized expansion cards like high-speed networking or video capture cards, all without creating bottlenecks. Beyond just the number of slots, the physical design of the chassis is built for easy upgrades. You'll often find toolless designs where side panels, drive bays, and expansion cards can be removed and installed with simple latches and levers. The internal layout is meticulously organized, with clean cable management and clear pathways to every component. This isn't just for aesthetics, it's for serviceability. It means an IT department or a power user can quickly swap a faulty drive or add more memory with minimal downtime, getting the machine back to work as fast as possible. It's a level of thoughtful, practical engineering you rarely see in the consumer space. This next point is one of the most important, yet often overlooked, differences: software certification. You can have the most powerful hardware in the world, but if the software you rely on for your job doesn't run properly on it, that power is useless. This is where ISV, or Independent Software Vendor certification, comes in. Major workstation manufacturers like HP, Dell, and Lenovo work directly with software companies. Think Autodesk for AutoCAD, Dassault Systems for SolidWorks, and Adobe for the Creative Suite to test and certify their machines for specific applications. What does this certification actually mean? It means that the hardware, the drivers, and the software have all been rigorously tested together to ensure they perform flawlessly. The NVIDIA RTX or AMD Radeon Pro GPU drivers, for instance, are specifically tuned and validated for these professional programs. This process guarantees stability, performance, and that all software features will work as intended. If you're an architect designing a skyscraper in CAD, you can't afford to have graphical glitches or random crashes. ISV certification is your assurance that the tool you're using is officially supported and reliable for professional work. This is something you simply do not get with a consumer or gaming PC. While professional software will likely run on a gaming rig with a GeForce card, it's not guaranteed to be stable. You won't have access to the optimized drivers, and if you run into a technical issue, the software vendor support team might just tell you that your hardware isn't certified and they can't help. For a business or a freelancer whose livelihood depends on that software, the peace of mind and dedicated support that comes with ISV certification is non-negotiable and a major reason to invest in a true workstation. So, we've covered the high-end hardware, the rock-solid reliability, the expandability, and the software certifications. Now we have to talk about the final, and for many, the most important factor, the price and who these machines are actually for. It should come as no surprise that workstations are significantly more expensive than regular desktop computers. A solid consumer PC might cost you anywhere from $800 to $2,500. A decent entry-level workstation, on the other hand, often starts where the high-end consumer PCs top out, around $2,500 to $3,000, and can easily climb into the tens of thousands of dollars for a fully loaded configuration. So why the huge price gap? You're paying for all the differences we just discussed. You're paying for the more expensive professional-grade components like Xeon CPUs and RTX Ada GPUs. You're paying for the R&D that goes into designing a more reliable system with features like ECC memory and superior cooling. You're paying for the extensive testing and validation that leads to ISV certification. And you're often paying for a better warranty and enterprise-level support, which can include next-day on-site service. It's not just a more powerful computer, it's a complete, reliable, and supported professional tool. This brings us to the target audience. Regular desktops are for, well, regular people. They're for general users, families, students, and gamers. They're designed for web browsing, office documents, media consumption, and entertainment. Workstations are purpose-built for professionals and researchers. The target audience includes engineers, architects, 3D artists, video editors, data scientists, and financial analysts. These are people whose work involves computationally intensive tasks and who cannot afford downtime or data errors. For them, the higher upfront cost of a workstation is easily justified because it's an investment that pays for itself through increased productivity, faster project completion, and greater reliability. So to wrap it all up, the difference between a workstation and a normal computer isn't just one thing. It's a collection of deliberate engineering choices. It's the sheer multi-core power of a Xeon or Threadripper CPU versus a consumer Core i7. It's the precision and stability of a professional RTX GPU versus the raw frame rates of a GeForce card. It's the data integrity of ECC memory, the robust cooling built for 24/7 operation, and the massive headroom for expansion that you just don't find in a standard desktop. These aren't just spec bumps, they represent a fundamental difference in design philosophy. A normal desktop is a versatile machine, a jack of all trades for the home and office. A workstation is a specialized instrument honed for the demanding, mission-critical tasks of creative and technical professionals. The ISV certifications and enterprise-level support are the final pieces of that puzzle, providing a guarantee of reliability that is essential when your livelihood depends on your digital tools. The higher price reflects this specialized engineering, R&D, and support infrastructure that backs up every single machine. It's a professional tool with a professional price tag. Ultimately, the choice comes down to you and your specific needs. If you're a gamer, a student, or a general home user, a standard desktop is almost certainly the smarter, more cost-effective choice. But if you're a professional who spends your days inside demanding applications like SAD, 3D rendering software, or complex data models, the investment in a workstation can pay for itself many times over and save time and increase productivity. So, take a look at what you do every day. Pick the right machine for your workflow.